Hi all. Have you ever experienced the process in developing a software? No? Good. Because today onwards, we are going to teach you software engineering. The art of developing software. First question, do I need to know a programming language to follow this course? The answer, of course not. I mean, not right now. Throughout this course, we are focusing on to provide you the basic theoretical concepts and standard practices on software life cycle, from initiation to the close of the software projects. So, Java, PHP, Python, whatever the language. We don't care. Because everything we are going to discuss here can be applied to softwares in any language platforms. Remember, software development doesn't mean it's only a developing or programming activity. It's a systematic process, involving many activities. That is why we call it as an engineering work. So the software developer is not the only role participating in here. In an actual software project, you could see business analysts, testers, project managers, software architects, and many more people. We will learn much about them, and what each do to come up with useful softwares. After successful completion of this course, you will get to know software engineering principles and techniques that are used in developing quality software products. Before learning to develop a software, we need to know what is a software, what kind of softwares can we build. We generally define softwares as a set of instructions given to a computing device that make the device work. When I say computing device, it can be your laptop, your desktop, your mobile, a scanner, a printer, a fingerprint machine, and even a washing machine. Any device which can process a computational functionality. The software that you build can be held in either on your computer's hard disk, or on a CD, DVD or on your pen drive. I mean, any storage device can be used to store it. But to process the instructions, it needed to be loaded into computer's random access memory, the RAM, prior to the execution of each instruction. Generally, software can be divided into two main categories: system software and application software. These are the two major categories. But if we want, we can further extend them as embedded softwares, web-based softwares, scientific softwares, etc. We'll come into that later. Let's first take the system softwares. The main characteristic we can find on them is, they operate and control the computer hardware. And also they provide a platform for running application software, our other major category. We can further divide the system software as system management programs, system support programs and system development programs. System management programs includes operating systems, OSs, such as Microsoft Windows, Linux and OS X, that formerly known as Mac OS X. And then operating environments. So, what is the difference between OSs and operating environments? Operating environment is usually not a full operating system, but is a form of middleware that rests between the OS and application. For example, the first version of MS Windows, Windows 1.0, was not a full operating system, but a GUI laid over DOS, disk operating system. So, Windows 1.0 was an operating environment. The next subtype, DBMSs. Systems that can store data in compacted form for further processing. MySQL, PostgreSQL, MS SQL and Oracle. They are the typical examples. Then system support programs. It includes the software that can optimize your device. It doesn't perform any business functionality, but supports the other applications to run smoothly on your computer. The subtype, system utilities, means disk cleaners, defragmentation tools or disk error checking tools. Software which performs a utility functionality. The subtype, Performance monitors means applications which can monitor the system resource usage and provide suggestions to optimize those resources. The RAM, hard drive, CPU etc. Security monitors can include firewalls, virus guards, and the necessary tools to guard your computer from harm. Then for system development programs we can take Java, PHP and Python kind of programming environments. And then the case tools. They are the software applications that used to build another software application. Typical examples are integrated development environments, IDEs, debugging tools, configuration management tools etc. So likewise, system softwares can span along three main areas. Then the other major category is application softwares. We can further divide it into two subcategories. One category is general-purpose application programs. For them, there is no specific user group. For example, applications of MS Office and OpenOffice, such as word processing and spreadsheet, are used by accountants, managers, doctors, teachers, I mean everyone in the world. But for specific purpose application systems, each software focus on a specific user group, or a specific business area, such as financial sector, education sector or medical sector. And then, apart from categorizing as system software and application software, we can further categorize software as follows. Number 1, business softwares. Main characteristic of these softwares is, they captures data to store in large databases. Maybe incorporates multiple databases. And then analyzes the captured data to come up with better management decisions to improve the business process. MISs are typical examples. Number 2, embedded softwares. These software reside in read-only memory of electronic gadgets that performs specific functionality. For example, washing machines, fingerprint machines, barcode readers and whole lot of other electronic devices having in the world. The computational tasks happening inside of them, carried out by these embedded systems. Number 3, web-based systems. These softwares can run through a network, to be accessed by anyone who have the authorization and accessibility. Number 4, AI softwares, or else we call them expert systems. Rather than performing numerical calculations, these softwares do logical reasoning to come up with conclusions for complex problems. Number 5, scientific softwares. These softwares can do simulations. Physical and chemical sciences are the main sectors that heavily uses scientific softwares. Okay. Now we know the types of softwares we can build. Developing system softwares is a tough job. You need to be an expert to develop such kind of softwares. But to develop an application software, especially a business software, it is somewhat you can do too. That's our main focus. After you specialized in a programming language, make you a professional software developer to build up business software, is our main aim. And in the next lecture, we'll talk about what are the important characteristics we have ensure to include in softwares. Thank you for listening and hope to see you again. Lesson content for software engineering prepared by Upega van de Bona, and this lecture series brought you by edupediaworld.com. I'm your speech synthesis voice, Brian. See you next time. Goodbye.